Good evening, everybody, and welcome to another episode of vBrownBag, the weekly IT video podcast where we bring you experts in the field of technology to talk about their favorite topics. Kind of like a geek show and tell where we get together and learn something new. Tonight, I am very excited and honored. We've got Hila Fish on, who I've been watching her presentations from afar for a little bit now. A fantastic presenter, and she's going to be talking about Terraform, something that is now near and dear to my heart. Wait a minute. Hi, Hila. How are you doing tonight?
I'm good. How are you?
I am doing fantastic. Super appreciate you coming on. This is kind of an out of band recording because we are doing it in the middle of my day because you graciously accepted coming on, and we had to make sure that you got some sleep tonight because you're in Israel.
Yeah, I am.
It's awesome. We have recently been having folks from Jakarta, from Mallorca, and I think you are the first person in Israel to present on the show. So, yeah. Huzzah! Awesome. Well, before we get started, let's do a couple of show notes. If you want to follow vBrownBag, you can follow us at vBrownBag. If you have any questions in the future when we post this recording, feel free to at vBrownBag or hashtag vBrownBag, and I will pick that up. Or if you want to talk to Hila directly, I highly recommend you follow her. She's at Hila Fish 1 on Twitter. Is there any other place that people can find you?
Yeah, I'm also on LinkedIn, so it's also an option, and I post like also the lectures that I give and other stuff that I share, mostly on LinkedIn and then on Twitter when I have the time. So LinkedIn is probably the better thing, yeah, to be consistent.
Wonderful, cool. All right, well, if you want to follow me, I discourage you from doing that. I don't do anything but cat Twitter posts and kittens and stuff like that. So don't follow me. But if you want to, I am at Mistwire on Twitter. Actually, I'm at Mistwire everywhere. So whatever social media thing you consume, that's where I'm Mistwire at. So with that, Hila, I would love to stop sharing and give you the power.
Sure. Let's do some stuff. Wait, I need to close things. Okay, yeah, I forgot.
I'm always the same way. I'll make sure the DMs aren't turned on, make sure nobody can text me.
It happened to me doing a lecture in Ireland, and then I was it was there was like a notification at the beginning when I just started out the lecture, and I'm like, okay, it will go away like only once, and that's it. And then it happened again. And I'm like, I stopped the presentation. I'm like, sorry, I have to take this, like I have to finish it to close it. I went to my laptop and said, like to the audience / to myself, it's very professional to not close the applications. So,
I found out that focus mode is my new best friend on my Mac. I switched over to Mac and somebody told me, hey, Chris, you could turn on focus mode and you won't get notifications. I was like, oh, tell me more. So
I will definitely check it out. I don't know that. So, okay, share screen. Okay, you see my screen?
Awesome. Yes, I can see it.
Okay, cool. So I'll just start.
Wonderful.
Okay, so for those of you who will join us, thank you for joining. And this talk will be about Terraform practices to enable infrastructure scaling. So Terraform is a great tool, right? It is used widely across the world. And this talk will be not only about Terraform usage and best practices, but also hopefully will make you think about Terraform in a broader context rather than just an infrastructure as code tool. So first of all, hi, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. I'm a firm believer in communities, and this is actually how me and Chris met. So we are both in AWS community. I'm a community builder, and Chris is a community hero. So yeah, communities rock. Since I'm talking about Terraform quite a lot, then I also got recognized as HashiCorp Ambassador lately.
Congrats.
I help co-organize DevOps Days TLV, which is the largest DevOps Days event in the entire world. And yeah, and also as you can see in this picture, I'm a lead singer in a cover band in my spare time, which is a lot of fun. Okay,
Which
so
could be its entirely own talk. That's amazing. I didn't even know that. That's awesome.
it is. I have a playlist. If you want, I can share it with you. Like
I need to put that in the show notes. Yes, absolutely.
No problem. Okay, so some disclaimers about things about this talk. I'm gonna cover only things about Terraform open source, because I assume things are implemented differently for Terraform Cloud or Enterprise. So everything you're gonna see here is applicable for Terraform open source. And most of the examples that I'm going to share here are from AWS provider, but of course, Terraform works with any cloud provider, so you can implement it in any cloud provider. And Terraform implementations can be sometimes good, bad, and ugly, and we can cover here a lot of these cases. Okay, so first of all, I want to start with quick wins. And when I say quick wins, basically I mean things that you can achieve in a matter of minutes to utilize Terraform in the best way possible. Also for Terraform, for enabling infrastructure and team scaling, but also generally speaking when it comes to Terraform. So let's see. First of all, version lock. So same as you lock versions for requirements, for Python in requirements txt or packages JSON lock, same goes for Terraform. You can lock versions in modules, providers, and Terraform itself. This is how we do it. And it's good because this is a meme by Anton Babenko, who's also a AWS community hero, but also a very, like I call him Terraform celeb. He's the maintainer of, one of the maintainers of Terraform AWS modules. And as you can see in this meme, sometimes you want to do things and then provider issues are getting in the way. So locking provider versions is good because at least you deal with the devil that you know, AKA syntax is known, the features are known, and you're not having any surprises. So the good thing is to lock modules, providers, and Terraform versions. The bad thing is to lock, but still allow breaking changes to occur. So if you lock, for example, to a minor version, then some breaking changes could potentially arise. And the ugly thing is to have no locks versions whatsoever, because again, you will face syntax issues, features that you didn't know that are planned to be, like changes that you need to face because at first you used syntax X, and then since you didn't lock the version, you will face like a changes. So you will have a lot of overhead and headache because of that. So just try to always lock the versions that you use. Second thing that I want to cover here is tagging resources. So basically any resource that you create in the cloud can be tagged. Why is it good? Because for cost management, to track also a logical arrangement of resources, what belongs to which project and stuff like that. And believe me, if you tag your resources, the FinOps team will thank you. And if you don't have FinOps team, congratulations, you are the FinOps team. So always make sure to tag the resources. And the examples that I show here is the examples that we have that we use for tagging. And also in AWS provider, you have a thing called default tags, which you can set default tags that will get inherited by any resource that are getting created through this provider. So for example, if I set up managed by Terraform, and then I create, doesn't matter what, Redis, EC2, VPC, doesn't matter, it will automatically get this tag, which is good because it's like, we have a saying, shager v'shkach in Hebrew. I don't remember how to say it in English, but it's like you say it once and then you forget about it. So that's awesome. And if you, this is like a classical use for this tag, but if you have any other things that are specific for your environment, for your organization, you can set it as well. So the good thing,
the direct translation isn't set it and forget it. What is the direct translation?
In Hebrew, it's like shager and v'shkach. Shager is like transmit or like teleport. Then shkach is forget about.
Teleport and forget. All right.
Yeah. Yeah. So the good thing is to tag everything that you can. Use default tags as much as you can, and you can also do PR enforcement, aka test that you will you can set up to make sure the tags are added. And if tags weren't added, then the PR merge will fail. And I'm going to cover this entire PR enforcement section later in this talk. The bad thing is to tag inconsistently because, as we know, consistency is key, and it will be very hard to manage costs and manage projects if the tags are inconsistent, so try to avoid that. And of course, the ugly thing is to have no tagging whatsoever. You will lose track of cost of everything, so please try to avoid that. And last but not least, in the quick wins section is remote state. So by default, Terraform works with a local state. And if we want to work in a team, if we want to have backups and stuff like that, and have audit on things, then we need to set the Terraform state in a remote backend. So this is how you set it up in AWS. You can set it up in S3 bucket, and that's basically it. So the good thing is to set it up to have like a remote and secured state. The state can be backed up if you enable S3 versioning, and to make sure Terraform state lock happens when you run apply. You can achieve that with DynamoDB, for example. And the bad and the ugly is basically the opposite. So if you have a local state, or if the state is remote but not secured or backed up, and if the Terraform state doesn't get locked during an apply, because then potentially there could be conflicts and then the state could be messed up, and this is not nice. Okay, now I'm going to cover the second nature section. And when I say second nature, I mean things that you should think about in your day-to-day when you work with Terraform. So first of all, using community models versus creating models yourself. So as we know, why reinvent the wheel, right? So if there are already community models out there that achieve whatever you're trying to achieve and cover your use case perfectly, and you don't need to struggle with it, so just use a community model. They are supported by the community. Someone else is managing them. Anton, for example, for the Terraform AWS models. There is also Cloud Posse, which are very, very familiar and known by the models. So others are maintaining them, adding features all the time. So they are maintained, supported. And also the PR enforcement that I mentioned before, they have tests on the code itself to make sure the code is in high quality, and that if others want to contribute, they can do it because these tests basically set up guardrails to make sure the code provided is in a high quality state. So if you can use community models, that's awesome. So use verified community models wherever possible. When I say verified, I mean that let's say in Terraform registry, until not recently, but until a year ago, something like that, it was like signed as verified, but HashiCorp removed this label from a Terraform registry, so you don't know what is verified and what not, or certified, let's say. So when I say verified, just check how many downloads these models had, because that way you can know that, okay, if it had millions of downloads, probably it is a safe module to use. The bad thing is to create a model of your own, but if you still maintain it as a community model, like you set up tests, you make sure it is in a high quality state, you make sure it is maintained and you don't forget about it, then it's still quite okay. And another bad thing is to use community model without a version lock, because I mentioned before, you should always lock versions. And the ugly thing is to both create a custom model and unmaintain it, because then it will drift and practically be unusable sometime, and to use unverified community models, because then you potentially could introduce malicious configuration in your code base. And if you do have to create your own models, make sure you make them stateless and clean as much as possible. Keep them generic. Do not repeat yourself if you don't have to. Keep it simple and stupid, and apply enforcements to maintain quality. And I know that I have like this build-up throughout this talk about the PR enforcement, but trust me, it's worth it. Next up, variables versus locals. So variables are just that, variables versus locals, where they are both, first of all, they are complex. You can use functions in them. Their values don't change between runs. So it's good. And I'm going to show you when it is like a classical usage of locals. And this is an example here of how to use it. So you can set up variables for project and environment, and then set up locals to have require tags, let's say in any project, and then the final definition of tags will be a merge between the required tags and the resource tags that contains the project and the environment. Oh, no, these are the required. You get the point. So you can merge, have a final definition, and basically have this final definition defined and run and applied throughout the code. So how to use variables and locals. So variables on the module side, their purpose is to be basically settings for the module configuration, but make sure you set up default or validation, because if not, and someone will use the module, then and they don't pass values to the variables, then the module will break and it's not great. So always make sure you set up default or validation for the variables, and you have an example here how to set up validation. In terms of locals in the module side, use it as a constant to be honored or relied on. So let's say I have a bucket module, like a module to create a bucket, and I want to have naming convention because, you know, buckets are, their names are unique throughout entire AWS, and we want to make sure we know all buckets that belong to our company, for example. So we can set up a naming convention for buckets in the locals, and then whoever uses this module are basically bound to this naming convention, which is good. We like this kind of bounding because we want to have a naming convention. So this is one example for that. And also just a small remark about naming conventions in general in code. Just have the cloud providers constraints in mind when you set up things that are related to characters, because maybe they have characters limitations and stuff like that. So just have that in mind. And then on the live side, and when I say live is where you call the model. So I like to use this metaphor for developers. So modules are like classes, and then live is the instantiation of the class. So live side, where you call the models. For variables, if you use them once, just set up default. If you use them per region, etc., just use tfvals file. And for locals, you should really avoid using locals if you don't really have to do it, because we want to keep the live side as simple as possible and leave the logic to the model side. But if you do have to use it, that's okay. And use data sources to pass outputs to the model, because that way you take dynamic configuration and pass it to the model, and it avoids the needs to set up anything hard-coded because you grab the information directly from the cloud. So the good thing is to use tfvals wherever necessary. You can also utilize environment variables, so it will avoid the need to add more variables because you have out-of-the-box variables that are there for you. Use locals to hard code one-time names, decrease code repeatability, and keep things generic as much as possible. A potentially bad thing is to create a multiple locals block, because Terraform allows you to create multiple local blocks. And if you don't really need to do it, then you can find yourself chasing locals and variables in different files. And you don't want to have that. We want to have a centralized place. And which leads me to the next point, decentralized files. Don't do it, just have variables tf and keep it there. And I'm gonna cover file structure in a bit. And ignoring environment variables, because then it will mean that you need to add more variables to maintain, and why do it, right? If you can utilize environment variables, so just do that. And the ugly thing is to hard code variables values where not necessary, because that's exactly the thing about variables, they need to vary. So just don't hard code if you don't really have to. And this leads me to file structure. How do you call, or how do you structure the files in a folder? Because as you know, Terraform just executes all files that have the suffix of tf, but for the sake of us human beings that needs to maintain the code, we should have a logical arrangement. And for that, we can take example or inspiration from a community standard as well. So in community model, we have the structure, a main tf for the main logic, and then variables for the variables, data for any data sources, and versions for the Terraform and the providers' versions. And then we have more things. So let's say we have a model to create a VM. we put it in main TF, but then if we need peripheral things like security groups or load balancer, then we will put them in separate files like that. And if you create a module that is quite complex, then you can create a submodule of things that can be standalone. So for example, in community models, for the VPC model, there's a submodule of VPC endpoint, and for the EKS model, there is a submodule of the node pools. So I can utilize the entire model, or I can just call, let's say I created an EKS, now I want to create more node pools, now I can just call the submodule itself, and that's it. So it helps me to reuse models and submodels on their own if it is possible. And also it also helps me to decouple variables if they are not really needed for the entire thing. So if I have submodule, I have the variables only for that, and then the variables TF file is not being gigantic, and I can manage it because they are spread through the modules or the submodules in the complex one. So if you have this kind of complex model, you can have submodels, and basically that's that. And again, this structure is meant for you to maintain the code better, to have logical arrangement, and that's the main thing, because again, Terraform will just execute everything that has the TF suffix. Okay, so this is a section that I really, really like to get to in this presentation, applying classic code best practices on Terraform, because I'm not saying that Terraform is a pure programming language. I don't think anyone thinks it's a pure programming language, but still, you can apply classic code best practices on Terraform. And how do we know that? Because even HashiCorp realized it's possible. Before Terraform 0.13, you couldn't even loop over models. And since the release of that version, you can loop over models with a single module call. So they realized that we should apply classic code best practices on Terraform, and we should do it as well, which means keep the code in source code management, keep the code as simple as possible, do not repeat yourself if you don't have to. Even principles of functional programming can be applied on Terraform. The code should be idempotent. And in regards to human and clean, I want to quote something by an article that I read online by Tis and Uo. I will have a reference slide at the end, and you will have a link there. So he said, and I totally agree, that the code that we maintain is meant for us human beings, okay? Because the computer doesn't care if the variables or whatever, if the code itself is ambiguous or not clear. If the syntax is okay, it will just get executed. But all things like naming conventions and refactoring and stuff like that are meant for us human beings to be able to maintain it better. If we are here, if I did something and then I look over this code in a year from now, so help the future me, right? So anything of this sort is for us to help us maintain the code better. So please try to apply classic code best practices, again, for us, for the sake of us human beings, and not for the sake of the computer itself. And we've reached this last section of this presentation, which is the long haul, which means things that you should think about in the long run and plan ahead when you work with Terraform. And before I will get to it, this is usually a question that I ask the audience. Of course, it's a rhetorical question because it's not a discussion yet, but that's the thing. We should always envision the infrastructure and the company's needs before we do anything. And I like to tell a story about that to emphasize what I mean. So we had like one of the daily syncs at work in my team. And then we discussed a tool that we maintain that currently runs on EC2 machines. And then someone suggests, let's move it to Kubernetes. And then the entire team was like, yeah, let's move it to Kubernetes. Yeah, awesome, like that. And I didn't say anything at that point. I thought to myself, like, okay, I want to move to Kubernetes because Kubernetes is pretty much the standard. And if I will work with it some more, because I already had the experience, but you know, Kubernetes is so complex, there's no such thing as I had enough. So any experience that I will have with Kubernetes is good for my career because I'll be more suitable for other jobs later on. So it's good for me to work with Kubernetes, but but I don't care about myself at this point. I care about the infrastructure and the application needs. So at that point, I said to my team, wait, hold your horses. Does the application even supports Kubernetes? Can it scale? Maybe it was a third-party tool. Maybe they say that the Kubernetes is not supported, or maybe there aren't many use cases in production for Kubernetes. So please, let's hold our horses and check first what's going on, and before we jump the gun and start migrating to Kubernetes. So that's the thing that I want to ask you here. Don't jump with buzzwords, okay? And don't do things just because other people are doing it as well. Check your infrastructure, check ahead, how do you envision the infrastructure going forward, the company needs, and based on that, choose the relevant infrastructure, choose the relevant software to help with these needs. So we planned ahead in my company, and that we understood that, first of all, Terraform is the way to go for what we want to achieve. And then we needed to start thinking about structuring the Terraform code base, because there are a lot of ways to structure the Terraform code base. And I want to share here how we structure the code base and why did we choose this structure. So this is the structure: a team, project, cloud provider, and region. And this is how it looks like. So we have live and models, and then BI for team, Airflow for project, AWS for cloud provider, and US East 1 for region. Why did we choose this structure? Two main reasons. First of all, Terraform as a platform. What does it mean? It means that any team that wants to create infrastructure in the cloud can join and can onboard to this repository. We have one repository for all teams that uses Terraform, and they can just utilize it. They get out of the box custom models that are relevant to my company, and they can use it. We have PR enforcement. We have tests that run on the code to check for any guardrails, the tags were added and stuff like that. So they get these tests out of the box as well. And they have a complete autonomy on the code that they add, because it relates to their team. So we utilize the code owners in GitHub, define the path, and then they can approve their own PRs, and they are not dependent on the platform team. So basically, that's a way to go. We wanted to set up Terraform as a platform. We wanted to enable infrastructure and team scaling, and that we proved to be awesome because everyone can just utilize it, and that's that. So this is one reason why we chose the structure. Another reason is small state files. So I hope that you know Terraform creates dependencies between its resources, and sometimes Terraform doesn't do a great job with these dependencies. So I had cases where I just changed a tag, and then I ran a plan, and then it's going to destroy something. Like, I just changed a tag. What's going on? So yeah, it could happen. So in order to help Terraform do its job properly, we should have small state files, because that way we eliminate a big blast radius scenario, and then the invalid dependencies scenario is decreasing because we have less resources to create, to have Terraform create dependencies on. So in this structure that you see here, the state file is kept in the US East 1 level, like the most specific one, which means the state files only keep Airflow resources for the BI team in AWS US East 1. So the state file is very, very small. We avoid big blast radius. Everyone is happy. Terraform plan shows exactly what I want it to show, and not any ambiguous things, and that's great. I want to cover here a bit about workspaces as well in open source. So workspaces is basically isolation units, and that you usually use workspaces when you have the same Terraform config for different customers, like AWS accounts or GCP projects. So it is isolated. You can utilize same Terraform config, and then since the workspaces are isolated, they don't see each other. So that was one example of usage. Another, which is basically coupled one, is when you have the same service in different regions. So let's say different customers, they all use the same service of login or financial service, then these services can be held in Workspaces as well. But I want to cover some notes about Workspaces before you jump the gun and go start working with them. First of all, you should really consider using a Terraform wrapper to avoid human errors. And why? Because how do you use Workspaces? With a CLI. Terraform Workspace select X. If I forgot to do the select, production incident. Okay, so try to avoid that and have a TF wrapper that will do the switching of the workspaces for you. Another thing is that you have less visibility, because once you, if you didn't use the Terraform Workspace conditional in your code, you don't even know that you are using Workspaces. And if you do Terraform Workspace list in the CLI, you can potentially see a lot of Workspaces, but it doesn't mean that all of them are in use. Maybe someone created them as a test and forgot about them. So you have less visibility with working with Workspaces, and this is something that you should consider. And also, you can't really utilize data remote state usages. It could be problematic because there isn't one like defined state when working with Workspaces. So you can't really share usages or utilize like things that are defined in one state in another. So it is very problematic. So if you don't really need to use Workspaces, try to avoid it, or at least read it thoroughly before you decide to work with it. And at least we can agree on one useful workspace usage, which is like a side branch. So I can create a workspace, test my syntax, test my infrastructure that gets created, and if everything is okay, then I can apply the code on the default workspace, which is production. So the thing about structuring your Terraform code base. So the thing is that if you plan ahead, if you really think things through, then it could help you set up small states and set up Terraform as a platform. If you don't plan ahead and think about your Terraform code base properly, then even organizational changes could potentially force you to restructure your code. And another bad thing is that using workspaces for the wrong reasons could be very bad. And the other thing is that really, if you structure in the Terraform code base that in a way that will allow a very big state files, huge state files, then it will create most definitely, it will happen, okay? Invalid dependencies, and then big blast radius, and it's very, very hard to come out of it. So please try to avoid that. Another thing that let's cover here, Terraform execution. So you should really do a remote execution, because that way you avoid setting up local credentials. You have audits out of the box and not run things locally, and then nobody knows that you ran it. Always aim for a remote execution. You can apply with a plan file, and that way you know exactly what is applied, and you're not no drifts are happening. And set up Terraform timeouts, because I had a time where I created like a auto-scaling group with spot instances, and the price wasn't right, and then I applied, and then I had to wait and wait and wait and wait. And most of the time I waited, but the first time, and this is why I'm telling you this story, is because I didn't wait one time. I was very impatient, and then I decided it's a good idea to just Control-C when I waited, and then it messed up my state. And of course, I didn't have a backup. So I don't know if they fixed it by now, and I can now safely run Control-C while running Terraform apply, but I don't want to find out. So try to avoid it as well. And basically set up a reasonable Terraform timeout that if you need to wait, all good, grab a cup of coffee, let it wait gracefully, and that's it. So ugly thing is really execute Control-C. Messing up the state is not nice. And the bad thing is to execute locally, because again, you need local credentials, no audits, etc. And last but not least, the build-up of this presentation, practices, enforcement. So basically, these are tests that you can set up to basically check anything that you want. So the standard things to check is that our resources tagged, like we're doing in my company. TF-lint to see if the code is reusable, if it's clean, if it is readable, if the syntax is correct, but also anything else. Like I can, like we integrated InfraCost, which basically checks the cost of the infrastructure that you added. And then I can have practices enforcement test that check that if the InfraCost is more than $10,000, for example, it will alert the FinOps team. So basically, the sky's the limit. You can set up anything that comes to mind, any guardrails, any important things for your company, like tailored things for your company, for your organization, and have it set up. And then that way you help other users contribute code, because they, even if they don't know all the rules, these guardrails will help them contribute better, and also to make sure that everything is done by the book, by your book. So these tests that I mentioned are, of course, applied also on Terraform AWS models. This is an example from the Terraform AWS auto-scaling module. So you can see in this screenshot that they check if the contributor formatted the code using Terraform FMT, if they added documentation, and if the code even works using TF-lint. So the good thing about practice enforcement is that really you can set up pre-merge linters, formatters, and logical checks. You can utilize it by GitHub Actions or utilize CI pipeline checks to do that. You can even set up a Slackbot drift reporter to check if the main branch equals the actual environment. Or you can utilize what we do in my company, which we use Atlantis, which is an open source tool for Terraform pull request automation, which once I open the PR, Atlantis runs a plan, a Terraform plan. I see the output, I see that everything is okay, and then I type Atlantis apply. Once I do it, two things happen. First of all, the code gets applied, and then the code gets merged to main. And this promises us that the main branch equals the actual environment, and then I don't need to create this Slackbot drift reporter because we have no drifts. The bad and the ugly is what happens if you don't set up a practice enforcement. So you could potentially have security issues and a non-compliant configuration introduced to your environment. And on the right, I've set up some open source tools to help you in your journey of introducing practices enforcement in your code base. So these are some of the tools I used by myself. Some I only heard good things about. So just check them out and see what could be helpful and useful for you. So you remember this question at the beginning? I'm going to ask you again, because I want to emphasize this is very, very important. I showed you a lot of things about Terraform, a lot of things about I mentioned things about your organization, because you really should have the organization interest in heart whenever you do anything that you do. So envision the infrastructure, envision the company's needs, and plan ahead while working with Terraform. Actually, not only with Terraform, anything that you have, any tools that you have, always have the infrastructure and company needs in mind before you do anything. So I hope this is big enough. I don't know, Chris, you can tell me if this is big enough. But this is the thing that I want the people to take out of this presentation. So really think about, like I covered a lot of things, but these are the majority, like the things that will generate the most impact. So think about the Terraform code base structure, because that way you can set up Terraform as a platform to enable infrastructure and team scaling, and to have small state files, which is very crucial when working with Terraform, and utilize and enforce practices to enable infrastructure and team scaling, and to have any guardrails that you need. And like any other tool, don't use Terraform in an ad hoc mindset. Plan for your future needs. Because what are projects in general in companies? Moving from one state to another, right? This is also, I'm quoting it from Thyssen-Wool's article. So in order to introduce projects to our company, to our department, we should really plan ahead and not have an ad hoc mindset, but plan as much as we can. And that way it will allow us to introduce projects to the environment, to the department. And then projects means progressing the company towards success, and eventually the company's success is your success. And these are some references that I mentioned throughout this talk. So Thyssen Wu article is here. Superlinter is an out-of-the-box test that you can incorporate in order to have like coverage for tests in the code, and some documents about workspaces, some documents about GCP and AWS labeling. Sorry, I didn't mention Azure. Sorry, people, I don't have anything against it. I just didn't use Azure, but I'm sure they have a document about labeling as well. And that's basically it.
Awesome. That was fantastic. That was an excellent primer, and a lot of that really resonated with me. The comment about architectural decisions and business best practices. I literally just had a conversation over the weekend with somebody that wanted to implement. It was interesting because it was a smaller company, but it was a smaller critical company, and they wanted to implement infrastructure as code. They wanted to implement CI/CD pipelines. They wanted to do this. They wanted to do that. And then they brought it up to the boss, and they were like, "This is a steady state application that doesn't even have auto scaling flex, and it's EC2 instances, and we don't care about downtime." And they were just immediately deflated. And I was like, "You didn't ask the business what they needed to begin with." They were ready to refactor it. They wanted, like you, they wanted to Kubernetesify all the things and containerize all the things, and they wanted to basically brush up their resume. And the boss was like, "Nope, you're sticking with crusty old PHP on an EC2 instance," and they were like, So understanding your business needs. Sorry.
Yeah. I mean, it's okay if the application doesn't need it. This is like a different conversation. You can drop, if you want to use cool tech stack, that's your prerogative, and you can leave that company and go practice other places. But this is what the application needs. You can't argue with that. If the customers are content and they get what they need, and the application doesn't need to evolve even more in a way that needs futuristic technology, then this is it, Yeah. So,
and that's actually what I recommended that the engineer do. I was like, well, you can start brushing up your resume, or you can be happy where you're at, or you can have an amazing home lab. one of the three. So the Atlantis cost estimator, that was something new to me. I'm gonna put all of the open source tools in the show notes, as well as your playlist for your cover band. So the Atlantis cost estimator, how does that work?
Basically, these are actually two different tools. So Atlantis is just solely for pull request automation, but we integrated InfraCost inside. So InfraCost is another open source tool, which checks for the cost for any resources that you're creating through the code.
Nice. Okay, I'll add those into the show notes as well. Very cool. This was a fantastic presentation. Tons of really great advice from where to keep your state files and how to minimize your blast radius, all the way up to practices. You've given me a ton of stuff to look into. I really appreciate this, and I'm sure that our viewers will too.
I really hope so, because this is why I deliver talks. I really like to give practical tips and advice, and basically prevent people from wasting their time and let them learn from my mistakes. So yeah, I always like to be as practical as I can. That's why I also talk a bit fast in talks, because I'm like, I have a lot of things to deliver, so I'll just talk fast. Like I can't remove things from the presentation. Like, people should know about it. So I'm just gonna talk fast, and maybe like afterwards they can put me on -70, I don't know, %. But that's the thing. Really want to deliver value and deliver information that will help people as much as I can.
Well, I listened to everything at 1.75, so you were absolutely perfect for me.
Cool.
Awesome. Well, everybody, thanks once again for sticking with us. I will have all of the links I can always tell when it's an amazing talk because I'm excited to like just go start Googling everything. So I've got a full homework list for myself. This is awesome. Thank you, Hila.
Thank you.
Cool. All right, everybody, have a wonderful night, and we'll see you again next week.
Bye-bye.